Hello everybody. This is a video to show you how to use the app Uenergy. Uenergy is a software. It's a software which calculates the energy audit in water distribution networks. The first thing that you have to do to make this software run is you have my website here, my personal website, and then there is a direct link to to download the software. Let me wait. Okay, here you have you have a download clicking on the following link. Well, Uenergy is an open source MATLAB-based, which requires for you as a user to have MATLAB installed in your computer, and also the toolkit of EPANet running in your computer. So it means that you should have downloaded the EPANet toolkit. You have one link to download this software, and it's also very useful to have downloaded EPANet. So when you click on here, you will be directed to this website, which is a website in which this software has been stored for you to download it. And here you directly press here and you download the files you will need to make it run. You download it. I've done it before, and then it is all these files are compressed, and they have been added in this in a path in my I have done it before, and I have exploded all these documents here. I have all the documents which were compressed here. So when I have this, you will see there are the two interfaces about Uenergy, also the files which are required, and you will find here four files three samples of water distribution networks that you can see. For instance, the network A is the network that has been used in this year 2017-2018 in the course of the Master of Civil Engineering in the University of Alicante, the second course. So all the students should have to calculate the energy audit of this particular network. So afterwards you open MATLAB. I have a shortcut here for MATLAB, and when you open MATLAB, you will have to be completely sure that MATLAB is pointing at this path in which we store all the documents before. Before making that software run, I have to press and that is something that I have to do to tell MATLAB that I'm using that compiler, and the software will find this compiler in this path. Of course, maybe you don't need it. It depends on your PC, or maybe you will need it. The point is that after that, you only have to type here Uenergy and press enter, and so you will get that interface. Later on, you will have, okay, that's a photo of the software. There are some information if you press here in help, in which it says that it has been developed by Miguel and Adrian, who are the authors of this work, and the funds in which we have been able to make it run, and the responsibility, etc. And apart from that, the software is really easy to be used. You only have to click here. There's only one input data. You only have to load the network. So you can choose these are the four samples. So I'm going to choose short, for instance, which is also a network we have been used. And later on, when we have uploaded the network, it appears it appears here one message saying that the file has been loaded successfully, and then the run button is you're able to click on here, and so when you click here you will get these results. It will take some time, as I will explain it later. And what are the results of that software? So that software tells you in numbers and also in pie charts that the injected volume, which is all of that, it has been 48,896.3 cubic meters. You have injected this volume of water in 240 hours, or what is the same, 10 days. So this water has been consumed on what? It has been lost it has been lost in leakage. It has, which is that number. It has also been not lost. It has been consumed by my consumers, which is my consumers are these figures, and some part of that has been stored in tanks. And finally, this is the final hydraulic performance, the network efficiency. This means that 65.58% of the water injected has been consumed by final users. So, which are our key goal as water distribution network managers? Our key goal should be that this water, this value was close to 1, as close as possible. Or, in other words, all the water injected in the system, we want it to finish to be consumed in the consumer's taps. And more or less the same is also calculated with the energy. You can see here that the input energy, the energy which which is necessary to satisfy the water demands, a part of that comes from the reservoir, and another part comes from pumps. So it means here the pump energy is equal to 8,276.97. So it means that this energy is the energy that the water managers should try to reduce, as this pumping consumption, this energy consumption in pumps, and the water utilities should pay for that. But at the end of the day, it depends on the type of network that you have seen. It depends on the layout. It depends on many things. But well, after that, all the energy that are leaving the system, thinking about the water network as a black box, is the useful energy, energy dissipated in friction through pipes, energy dissipated in leakage. There are also energy dissipated in bulbs, but here, as there is not any bulb, energy dissipated is equal to 0. But if there were any bulb, the UAEnergy always also will provide you that information. And finally, there's still some energy which are lost in tanks. So these compensation tanks are tanks which tends to be filled at night when there's not any water consumption, and they help in the providing water in peak consumption hours of the day. So, and finally, we have an error here, which is not exactly 0, because when there are tanks, it's not so easy to reach this high percentage. But well, the results are quite good. Think about an error in the 0.01%. So for us, as engineers, we can consider it as okay. Well, thank you very much for watching this video, and I hope you to enjoy running Uenergy, and I hope you I hope this tool was useful for you in your career. Thank you very much. Ciao.